Welcome back to another Daishinfinity video. In this video, we're going to talk about the proof of e to the I times theta 1 plus theta 2 is equal to e to the I times theta 1 times e to the I theta 2. This is the addition of angles in the complex plane, and I would like to prove this to you using the Euler formula. So before we dive right in, we have to show that e to the I times theta 1 plus theta 2 is equal to e to the I theta 1 times e to the I theta 2. Now e to the I theta is equal to cosine theta plus I sine theta. The proof will be maybe later in the future, but I don't have to prove this. It's because I will be proving this in another video. So since we have this, we can say that e to the I theta 1 plus theta 2 is equal to e to the, to cosine, so the real part of the complex, cosine theta 1 plus cosine theta 2 plus I sine theta 1 plus theta 2. Now we know the addition theorems of cosine and sines. Cosine of A and B is equal to cosine A cosine B minus sine A sine B. This is also another proof in another video. And the sine of A and B is equal to the sine of A cosine B minus the this cosine A sine B. So we're going to use this in this equation in order to prove this. So this will be equal to or equivalent to cosine theta 1 cosine theta 2 minus sine theta 1 sine theta 2 plus I sine, so I times sine theta 1 cosine theta 2 minus cosine theta 1 I sine sine theta 2. Now we're going to multiply this out with the i's, so we're going to get cosine theta 1 cosine theta 2 minus sine theta 1 sine theta 2 plus I sine theta 1 cosine theta 2 minus I cosine theta 1 sine theta 2. And we notice that cosine theta 2 cosine theta 2 are the same, and sine theta 2 sine theta 2 are the same, so we can group them and then use the negative sign 2 in order to get it out, so that we only have the addition of them. So now we have cosine theta 2 times what will give you cosine theta 1 cosine theta 2, obviously cosine theta 1, plus I sine theta 1. Then we have negative sine theta 2. And I would like to get the I sine theta 2 out too. Let's put the plus here. It's because if we have the same thing here, then if we would have the same thing here as this one, then we can actually prove it, because this should be e to the I theta 1, and here's e to the I theta 1. I hope so. And this will be e to the I theta 2. So that's why we want to prove it in this way. So if we take out I sine theta 2, then we have to ask ourselves, I sine theta 2 times what will give you minus sine theta 1 sine theta 2. Obviously minus sine theta 1 over I. And I sine theta 2 times what will give you minus I sine theta 1 sine theta 2. Obviously minus cosine theta 1. Okay. Now what we're going to do is we're going to write it down as this one. We're going to write it down as e to the I theta 1. So we can write it down as cosine theta 2 e to the I theta 1 plus I sine theta 2 times minus, now we're going to multiply both sides of the fraction by I, and then we're just going to leave it as it is over here, and then here we will get cosine theta 2 ei theta 1 plus I sine theta 2 times negative will be positive I sine theta 1 minus cosine theta 1. And this indeed is equal to e to the I theta 1. So actually, we have just come to the same conclusion as I actually assumed, which states that we can take this e to the I theta 1 outside. So this will be e to the I theta 1 times cosine theta 2 plus I sine theta 2. And this indeed is equal to e to the I theta 2. So now we have proven that the whole thing is equal to e to the I theta 1 times e to the I theta 2. I hope you guys like this video. Please like and subscribe. If you have any questions, comment, and if you don't have any questions, I hope I will see you in the next Daishinfinity video. See ya.